Look around you. In the whir of a blender, the hum of your car, the silent sweep of a clock's hands, even the vast machines that build our world, an ancient principle is at work, unseen yet utterly essential. For millennia, humanity harnessed power, water, wind, muscle, but a fundamental challenge remained. How do you reliably transfer that power? How do you change its speed, its torque, its very direction? The earliest answers were ingenious, yet rudimentary. Think of simple wooden pegs on the rim of a water wheel, crudely engaging another. But a quantum leap in thinking emerged from the Hellenistic world. Around 200 BC, a device of astonishing complexity was created, the Antikythera Mechanism. These weren't just for brute force, they were for calculation, for mimicking the cosmos. The concept of precisely interacting toothed wheels was born, used by Hero of Alexandria and later Roman engineers in mills and lifting devices. But these early gears had a problem. As teeth engaged and disengaged, the transfer of motion wasn't smooth. There was shuddering, wear, and lost energy. The shape of the tooth itself was the culprit. The Renaissance and Enlightenment brought mathematical rigor. Thinkers like Girard Desargues and Philippe de la Hire explored roulettes, curves traced by points on rolling circles. The challenge: find a tooth profile that transmits uniform motion. While cycloidal gears offered improvements, particularly in clockmaking, the true breakthrough was the involute curve. Imagine unwrapping a string from a cylinder. The path traced by its end is an involute. When two involute gear teeth mesh, their point of contact always lies on a straight line tangent to their respective base circles, the line of action. This geometry ensures a constant angular velocity ratio and primarily rolling contact, minimizing friction and wear. The mathematical elegance of the involute was potent, but realizing it in metal accurately and repeatedly was another hurdle. The Industrial Revolution, with its insatiable demand for power, provided the impetus. Steam engines, lathes, looms. Factories hummed with the power of these newly precise and durable gears. Mass production of interchangeable parts became possible. Gears weren't just for clocks anymore. They were the sinews of industry. As technology advanced, so did gear design. The 20th century saw an explosion of specialized forms, each engineered for specific tasks. From the transmissions in our cars to the actuators in aerospace, these sophisticated designs pushed the limits of materials, lubrication, and precision manufacturing. Today, the gear is a ubiquitous, often invisible, marvel. Its evolution mirrors our own journey of understanding, from intuitive mechanics to profound mathematics, from handcraft to high technology. Each precisely formed tooth is a testament to centuries of human ingenuity. So, the next time you witness the effortless translation of power into motion, remember the silent revolution of the gear, the toothed titan that continues to drive our world forward.